This video is to explain to you how you find focus and directrix for different parabolas. And as we found out in the investigation, the way you find the A value from the P value is with this formula here, which is not the simplest thing in the world, but at least there's only a couple numbers in it, and I'm going to give you these formulas on the exam, so you don't need to memorize them. Okay? And what's kind of nice about these is that, look, actually, the if you look at it, the to go from P to A, or to go from A to P, it's basically the same formula. You just switch the A's and the P's. That's the nice thing about these rational functions. Okay? So I think it's easier if I just demonstrate how it works. So let's do that. Okay? So let's start out with the most basic parabola, y equals x squared. Okay? Or if you remember, y equals x squared, it goes through the origin because it's a parent function. And if you remember from the investigation, the directrix and the focus of the y equals x squared parent function, they are located in the following locations, right? And the positions of the focus and the directrix are 1/4 from the vertex and 1/4 from the vertex. So the equation of the directrix is y equals negative 1/4, right? Because it's 1/4 below the x-axis. And the location of the vertex would be 0, 1/4, right? So basically, by knowing that the parent function has a p-value of 1/4, we already can figure it out. But let's say you don't remember that. You could use the formula, okay? So if we know that it's the parent function, which means a equals 1, then we could figure out the p-value by using the formula 1/4a. If a is 1, then p is equal to 1/4, right? So basically that's saying the distance from the vertex, which is this red dot here, to the focus, which is this blue dot here, is 1/4. The distance from the red dot vertex to the blue line, which is the directrix, is also 1/4. Okay? So that's how you find it for the parent function. Now let's try to do a function that's slightly more difficult, like, for example, y equals negative x squared. Okay? If you have y equals negative x squared, if you remember, the negative in negative x squared inverts the function. Okay? And let's see. So let's draw a picture of that. If you have a negative x squared, it looks like the parent function, but it's inverted. Okay? And if the parent function is inverted, then you are going to have a directrix and a focus that's kind of inverted also. So instead of having the focus above the x-axis, it's going to be below the x-axis. Instead of having the directrix below the x-axis, it's going to be above the x-axis. Instead of having a directrix with the equation y equals negative 1/4, like we have here, we're going to have a directrix that's going to be y equals positive 1/4 because it's above the x-axis, right? And the focus location is going to be 0, negative 1/4. Okay, so everything's just inverted. All right? Okay, let's take another one that is not quite so easy. Y equals x squared plus 2. Okay, so in this case what we have is we have the parent function, but it is translated up 2 units. So instead of crossing at 0, 0, the function crosses at 0, 2. Now, if we were going to draw the directrix and the focus for this one, it would still be a distance of 1/4 away from the vertex to the directrix. It would still be a distance of 1/4 away from the vertex to the focus. So if the vertex location is exactly 2 units above the x-axis, which would be 0, 2, then the focus location would be 0, 2 plus 1/4. And if you remember your fractions, that's equal to 0, 9/4. Okay? And maybe if you're bad at fractions, maybe your calculator can help you with that. Let's see. So if we have 2 plus 1/4, and we want to say, let's put it in fraction mode. So we'll put it in mode, and then we'll go down to how we want our answers, and let's say we want our answers in fraction form. So we'll say 2 plus 1/4, 9/4. Okay? If you got one of those calculators that doesn't have fraction form, you can always do this. You go 2.25, and then you do math, and then fraction. Okay? You can do that the same way. Okay? So what would be the location of the directrix? The directrix would be, instead of y equals negative 1/4, it would be y equals negative 1/4 plus 2, because we've raised it by a translation of 2. So 2 minus 1/4 is 7/4. Okay? Okay, so our directrix here is y equals 7/4. All right, let's try one more. Let's try this one here. Y equals negative x squared minus 1. Y equals negative x squared minus 1. So on this one, we've got an upside down parent function again, and it's lowered by 1. It goes down by 1. So instead of crossing at 0, 0, it crosses at 0, negative 1, right? And if I was to draw the directrix and the focus, it would be here and here. Remember, since the parent function is a standard parabola function with the a value of 1, we know that the distance from the directrix to the vertex is 1/4, and we know the distance from the directrix to the vertex to the focus is 1/4. So since the vertex is 0, negative 1, this focus would be 0, negative 1 minus 1/4, which would be 0, negative 5/4. You can check that on your calculator. And the directrix, instead of being y equals negative 1/4, would be y equals negative 1/4 minus 1, or actually y equals plus 1/4 minus 1, which would be negative 3/4. Okay? Let's try to do a couple that are slightly more difficult, like this one here, y equals 3x squared. Okay? Y equals 3x squared. Okay. Y equals 3x squared is not a parent function. It is transformed, right? Because the a value is 3. So it doesn't really matter what it looks like because we're just sketching. Let's see. What would be the p-value that corresponds to an a value of 3? Well, let's put 3 in for a. We're going to get 1 over 4 times 3, which is 1 over 12. So our p-value is now 1 over 12. Since this function here has a vertex at 0, 0 still, because there's no translation, we know that basically the directrix and the vertex are going to be here and here, centered around the vertex of 0, 0. The equation for the directrix is going to be y equals negative 1/12, because that's the value of p. slightly down from the vertex. And then the focus is going to have a location of 0, p, which is 0, 112. Okay, positive 112 because it's above the vertex. Okay, now we're going to do one more. Which would be y equals 3x squared minus 3. Or let's do minus 4. Okay, so 3x squared minus 4. So that again would be a parabola that points up, right? But the difference between now and before is that now this one is going to have the vertex at 0, minus 4. 0, minus 4, right? Because it's got a translation down of negative 4. Okay? Now let's figure out where the directrix and the focus are. Well, we have an a value of 3, so remember, if you have an a value of 3, that means that the p value is going to be 1 over 12, okay? And that means that the directrix and the vertex are located 1 over 12 below and 1 over 12 above the vertex, okay? So if the vertex is 0, negative 4, that means the directrix is y equals negative 4 minus an additional 1/12, which is equal to negative 49/12. Okay, you can confirm that on the calculator if you need to. And then the focus location is going to be 0, negative 4 plus 12. Okay, and so if I wanted to simplify that, I would put negative 47/12, something like that. Yeah, that makes sense. And then, oh, whoops, look what I did. I forgot to put the negative here. Okay, so be careful about that. Okay, I'm just going to confirm on my calculator here. I'm going to do negative 4 plus 1/12. And yeah, it shows me negative 47/12. Okay, so our focus is that, and our directrix has this equation here. Okay, so with that, I think you can do some IXLs for this.